Now, quadratic equations are equations that are going to have an x squared term to them, or they're going to have variable multiplication to create power. They do not make lines, they make parabola graphs that kind of shape like a letter U, but there are different forms for quadratics also. So quadratic equations are either going to come into standard form. Standard form is y equals, and what you have is you have the quadratic all laid out together kind of like a train. You got the front car, ax squared, you're going to have squared here, otherwise it would be a line. You may have things behind it, bx plus c, and there you have it. Now, that's a form. This form right here is actually in what's called vertex form, which allows you to find the beginning of the graph. I would just look at this right now and say this quadratic, this parabola starts at 4, 2 in the first quadrant. This value tells you it opens up, it's fairly tight. But that aside, if I want to just change this into standard form, what you have to do is blow this up. You need to multiply here and do order of operations and get this into that form. So I'm going to have to take x minus 4 and square it first. So you may remember how to do that in your head. If you don't, you just got to multiply those two binomials, or that binomial times itself. So I lay it out and I do the FOIL technique, or simply distributing twice. So x times x is x squared. I've got a negative 4x, x times negative 4. I call that the first and the outsides. Then I bring the second factor through, and I've got another negative 4x, and I've got a positive 16. Now when you put it all together, I have x squared. The guts, the middle term, is negative 8x, and then the tail is 16. Now that's not my answer. That's just this binomial squared. Now should I add 2 to it, or should I multiply by 3? We're following order of operations. We need to take care, we need to multiply. So it's 3 times this trinomial now. Alright, so now I'm doing the distributive property, bringing monomial through this trinomial. So y equals 3x squared, negative 24x, positive 48. Now this little 2 is just a combine on, and that's going to be combined into the constant back here. So 48 and 2 more makes 50, and that would be the same exact quadratic equation in what's called standard form, where it's all blown up into one large expression. Okay? Alright. This is another way you can see a quadratic, and you say, well, Mr. Kohler, where's the power? Where's the power to? Well, we don't see it. Okay, but this x positive 4 is timesing this x minus 5, and I'm pretty confident when we take x times x, we'll get x squared. So this is actually called factored form, or x-intercept form, or you can find the x-intercepts of the parabola, if they have them, and then you can graph it pretty easily. This is not graphing, this is just converting into standard form. So again, standard form is blown up form, you multiply it out, and you get standard form. So I just got to multiply this times this times this. Now if you remember, if you have 3 things in math and you're multiplying, there's a property called the associative, where you group up with your friend. You kind of like friending on the on Facebook or something, where you group up and you multiply that out. Now personally, me doing this, I'm going to multiply my 2 binomials. I'm going to save the 3, and I'm going to multiply through that at the end. Okay? So I need to go and do a little binomial multiplication. So x plus 4 times x negative 5, distribute, and this is just bringing each factor through both of these terms accurately. And the 4 comes through, positive 4x, negative 20. You put all the stuff together like a bowl of chili, and you got that trinomial product. That now is going to get multiplied by this 3. So that has got to go into parentheses. And then I can distribute the 3 through there and get my quadratic in standard form. So 3x squared, negative 3x, negative 60 would have the goods. Okay? So we got forms for linear equations, namely slope-intercept in standard form. And you also have a standard form for quadratics, where it's all laid out in a grouping ax squared bxc. Okay? So there is an example of converting from one equation form to another with linear equations and also quadratic. I hope that helps, and we'll see you on our next little video. Thank you.